Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 641. Please turn to it, page 641, and today is our lesson number 63. Let's take a look at it, see what we have. It says, I do not know how to pronounce this name, Senai, I believe, customized her bicycle by exchanging the front wheel for a wheel that had half the diameter of the back wheel. Alright, so she took out the original wheel that was in the front and put in a new one which has half the diameter of the back one. Alright, good for her. Now when she rides the bicycle, how many revolutions does the front wheel make for each revolution that the back one makes? Alright. So she exchanged the front wheel for a wheel that has half the diameter of the back. So here's our front wheel, and I'm going to do my best here, and here's the back wheel here, and here's a bicycle. The very first thing we have to realize is that because the front wheel, let's make a note here, front wheel has half the diameter. If it has only half the diameter, it's a smaller tire, smaller wheel, whatever you want to call it, and therefore use your brain. Think about it for a second. If it is a smaller wheel, if it's a smaller tire with a smaller radius or smaller diameter, same thing, will it have to make more revolutions for a given distance or fewer revolutions? If you travel a given amount of distance, let's say 1 mile, will that front wheel end up making more revolution or fewer revolution? Of course, more revolutions, because it's a very tiny wheel. Which means any answer choice that is less than 1 is ridiculous. See, D and E are just stupid. They cannot be right answers. Those D and E are answer choices only for those people who are not paying attention. And they switch the wheels. Do you understand? Is the front one that's smaller. So let's make up numbers here. The easiest thing to do is just to make up numbers. We're going to pretend that the front one, let's pretend that the back one has a diameter of 8. If it has a diameter of 8, then it has a radius of 4. So let's call it the radius of the back one. And here is the radius of the front one. And the radius of the front one is going to be 2, because it's half the diameter. If it's half the diameter, it's half the radius. What's the circumference of this guy? Circumference of this guy here is 2 pi r, which is 8 pi. What's the circumference of this one? 2 pi r, which is 2, which is 4 pi. What do you see from here? What we see from here is that every time the back tire makes 1 revolution, it travels approximately 24 feet, assuming that we're measuring in feet here, because pi is approximately 3.14, whatever it is. So let's say 3, pi is approximately 3. So this one travels about 24 feet, and this guy is going to travel about only 12 feet. It travels half the distance. The front wheel in each revolution travels half the distance of the back wheel. Front wheel travels half the distance of, I'm not going to write everything, just listen to me. Front wheel makes half the distance of the amount of distance that the back wheel makes. The back wheel travels when it goes through 1 revolution. And because it travels half the distance, it's going to have to make twice as many revolutions. That's all. That's all, because it's going half the revolution. The circumference of the front wheel is half the circumference of the back one, so it has to go twice as many revolutions. The answer is C. The question was, how many revolutions does the front wheel make for each revolution of the back wheel? For each one revolution of back wheel, the front wheel makes 2 revolutions because it travels half the distance in each revolution of half the distance of the front wheel of the back wheel. Do you understand? Number 12. Let's go on to number 12. Otherwise, we're going to keep beating the dead horse. I pick up these expressions from God knows where, and I feel like I need to flaunt them. Do you understand? Why not? I know how to use it. Or at least I think I do. I hope I really use it in the right context. Number 12. A list of numbers consists of p positive numbers and n negative numbers. Alright. So we have p positive numbers and n negative numbers. Alright, so far so good. A number is picked at random from the list. The probability that the number is positive is 3/5. The odds of picking a positive number, we are told, the odds of picking a positive number, we are told, is 3/5. The odds of picking a positive number at random is 3/5. What do you surmise from that? What do you gather from that? What do you infer from that? If it's 3/5, the odds of picking positive numbers, odds of picking a positive number is 3/5. Then this implies that the odds of picking a negative number must be 2/5, because 3/5 plus 2/5 has to add up to 1. What does it tell you? It tells us this in turn tells us that out of every 5 numbers, 3 are positive and 2 are negative. Are you with me so far? That's what it tells us. And the question simply is, what's the ratio of negative number to positive number? What's the ratio of n over p? Well, there's your n. This is your n. And this is our p. Of course, we don't have 3 and 4. Maybe we have 30 and 20, or maybe we have 15 and 10. It doesn't matter. It's some multiple of 3 and 2. So therefore, the ratio of n over p is going to be 2 over 3. That's it. For every 2 negative numbers, we have 3 positive numbers. The ratio is 2 over 3. Number 13. Number 13. Let's do one more. Just like number 12 before I go to number 13. Okay, listen to me. I have a box full of marbles. There are blue marbles and there are red marbles. I'm telling you that the odds of picking a blue marble is 3/7. If odds of picking a blue marble is 3/7, that implies that the odds of picking a red marble must be 4/7. Can you tell me what is the ratio of blue marbles to red marbles in this box? Well, the ratio of blue marbles to red marbles must be 3/4. Can you tell me what's the ratio of red marbles to blue marbles in this box? Well, the ratio of red marbles to blue marbles must be 4/3. So depending on how the question is phrased, you have to pay attention to the wording and just go for it. Are they looking for a ratio of blue marbles to red marbles? Are they looking for the ratio of, or are they looking for the ratio the other way around? Are they looking for the ratio of boys to girls, or are they looking for the ratio of girls to boys? So if you have a class full of 30 students, we are told, we have a class full of 30 students, and we are told that if you were to pick if you were to pick one student at random, okay, you make a list of all the students on a piece of paper and you throw them in the box and you just pick one at random, and we are told that the odds of picking a boy is 1/3. Well, if the odds of picking a boy at random out of a class of 30 is 1/3, then the odds of picking a girl must be 2/3. And the fact that the fact that there are 30 students here actually plays no role. It doesn't matter whether there are 30 students or whether there are 3 students or whether there are 3 million students. If the odds of picking the boys 1/3, the girls must be 2/3. Do you understand? So what's the ratio of boys to girls in this class? Well, the ratio of boys to girls in this class is, for every 1 boy, there are 2 girls. Lucky boys. Do you understand? That's all. Now, if you can find out which class that is, I want to sign up. Number 13. The total daily cost in dollars of producing X units of certain product is given by a function. Here is our cost function. C of X we are told equals to 600X minus 200 over X plus K. Yeah, pretty nasty looking thing, isn't it? And of course K is constant. We are told that an X we are told is less than or equal to 100, which actually plays no role here. If 20 units were produced yesterday for a total cost of 640, what's the value of K? Well, they tell you what the cost is. They told you that the cost is $640. We are told that there were 20 units produced. We just put in 640 for cost. The cost of producing 20 units, we are told, is $640. Is $640. So cost of producing 20 units is $640, which must equal 600 times 20. You just replace the X by 20. That's all. Minus 200 over X, which is 20, plus K. That's it. So all we have to do is solve this equation for K. That's all there is. I'm going to erase the top part now so that it's not too crowded, but that's it. That's our cost function, 600 times X. We replace in place of X we put down 20 because we're producing 20 units, we are told. 600 times 20 minus 200 over X, which is replaced by 20, and the total cost of producing the 20 units is $640. That's all. The very first thing I want to do, the very first thing we should do, what should we do? Let's see. Should we do anything at all? Oh, bloody hell. I'm looking here to see how I did it here. I'm trying to figure out. There are several ways to go about it. My first instinct was to multiply the entire equation by 20, but on second thought, I really am not too keen on that because I don't want to multiply the bloody 640 by 20. I don't want to do that. Let's just divide this quantity. 600 times 20 minus 200 over 20 can be written as, this can be written as 600 times 20 over 20 minus 200 over 20. You see? For example, 10 plus 4 divided by 2, 10 plus 4 is 14, 10 plus 4 is 14, 14 divided by 2 is 7, and that can be written as 10 over 2 plus 4 over 2. Because 10 divided by 2 is 5 and 4 divided by 2 is 2. So 5 plus 2 is 7, you see? It's still 7. That's what we are doing here. 600 times 20 minus 200 over 20 is same as 600 times 20 over 20 minus 200 over 20. That's it. And we find out that the 20 drops out here, and here 200 divided by 20 is just 10. So this whole thing actually, this entire thing that you see here is actually 600 minus 10. Oh, that's actually pretty simple. That's 590. What the hell? This is actually much simpler than I thought. It's just 590. Oh, we're almost done. 640 equals 590 plus K, and therefore K would be 640 minus 590, which is 50. What do you know? That turned out to be much simpler than I was expecting. K equals 50. The answer is B. The answer is B. Let's do 14, shall we? Let's do 14. I'll give you a chance to absorb it. There you go. While I absorb my tea. I promise I will not use this line for more than 1,000 times. Number 14. For how many ordered pairs of positive integer xy is this quantity 2 times x plus 3 times y less than 6? Alright, so the ordered pair is x and y. We have an ordered pair of x and y, and for a given value that we put in here, it has to be less than 6. And they have to be, we are told that they have to be positive integers. So why don't we try 1 and 2, see what happens. Let's try 1 and 2. 1 and 2, if x is equal to 1, and y is equal to 2, 3 times 2 is 6, 6 plus 2 is 8, this equals 8. 8 actually does not work because 8 is not less than 6. That doesn't work. Why don't we try 2 and 1? Let's make x equal to 2 and y equal to 1, because you know, with 3 times y, this 3 times 2 is already 6. Let's make it 1 plus 2 times 2. 2 times 2 is 4, 4 plus 3 is 7, and 7 is not less than 6. Bloody hell, what are we going to do? And they don't give you answer choice as none. For how many ordered pairs of positive integer xy is this quantity less than 6? It's lucky for us that they don't give us none as one of the answer choices. They should have. Can you think of one ordered pair where this would hold true? Can you? Here's what's going on. You see what happens. Because of the fact that they have to be positive integers, listen very carefully. Because of the fact that they have to be positive integers, even the smallest value that you can think of, 1 and 2, you can clearly see the problem. If you put in 1 for x and 2 for y here, this becomes 6 already. 3 times 2 is 6 already. And by the time you add another positive quantity, that's not going to be less than 6. And if you put 1 over here, that's fine, that's 3. But then if you put a 2 here, 2 times 2 is 4. Again, that's not going to be less than 6. There is only one ordered pair for which this will hold true. And that ordered pair is 1, 1. 2, 2 will not do. 2, 2 will not do, because you can't put 2 at all, because as soon as you put 2 here, this 3 times 2 becomes 6. And by the time you add some other positive quantity, because they are both positive integers, by the time you add another positive quantity, obviously it's going to be whatever this is going to be more than 6, because 3 times 2 is already 6. 1, 1 is the only ordered pair where this would hold true. As we can see here, 2 times 1 plus 3 times 1, 2 times 1 plus 3 times 1 is 5, and 5 is indeed less than 6. 5 is indeed less than 6. The question was, for how many ordered pairs is this statement true? The answer is only 1. Only 1. And that ordered pair is 1, 1. X has to be 1 and y has to be 1. That's it. We are done with this page. Tomorrow we'll continue on the next page. Next page is actually going to take even more time than the following page, even though on the following page, on 643, on page number 643, questions are hard problems, whereas on page 642 there are 3 medium questions and 1 hard, but it's going to take a very long time because of the fact that there are 4 of them, as opposed to the following page on which there are only 2. So we'll cross that bridge when we get to it. Do you understand? I'll see you tomorrow, okay? Bye now.